Alright kids, today we're going to talk multi-equation problems. These are going to be about as complicated as we get throughout the physics section. They're very doable, but we're going to try working it down so that you have a systematic way of approaching these. As always, my suggestion would be to look at the problem, pause it, try it out, and then hit play again and watch my solution, see if you get the same thing I do. You're going to get much more out of this if you are actually attempting this yourself in writing as opposed to simply watching what I do. In any case, first thing that I do in every single set is try to figure out what they're asking for. What is the end product that we're looking for? So, for number one, a rocket is launched. A rocket takes 3.8 seconds. At that point, the rocket has a final velocity of 26 meters per second. If the rocket has a mass of 2.4 kilograms, what's the force applied to the rocket upon launch? So, what was the force? I guess is what we're trying to find. So, force is our final solution, or our final product. Now let's go through and figure out what we actually have. The launch takes 3.8 seconds. So time is going to be 3.8 seconds. It's an equals. And at that point, that rocket has a final velocity of 26 meters per second. So VF equals 26 meters per second. Being that we're talking about a rocket, there is some implied thing here that the VI is going to be 0 meters per second because rocket, well, if it's launched, it's going to be starting from rest. Continuing through, if the rocket has a mass of 2.4 kilograms, so mass equals 2.4 kilograms, what was the force? So at this point, we have all of the information that we were given. We know what we're looking for. I like working backwards. I know that I'm looking for force, so I'll start off with force equals mass times acceleration. I have not been given a force. I know that's what I'm looking for. I have not been given an acceleration, so I know that I've got to solve that thing somewhere. But I have been given a mass, and that mass was 2.4 kilograms. So I know I simply need to solve for this. Well, I've got a second equation over here based on VF, VI, or VF, VI, and T that I could take acceleration equals VF minus VI all over T and plug some numbers in such that we could solve acceleration and then take that number and plug. So in this case, our VF was yellow. That was our 26 meters per second. Minus your VI, which was orange, the 0 meters per second, and then we've got that 3.8 seconds was time, and once we set all of that together, and we get our 26 over 3.8, that leaves us with a 6.84 meters per second squared, and that whole thing, our acceleration, is going to get put into here. Okay, that's our little arrow. So we end up with 2.4 kilograms times 6 times 6.84 meters per second squared. And that's going to give us a final force. Force equals 16.42 newtons. So in terms of your final answer here, this was the actual force applied to the rocket upon launch. Right. So again, if that makes sense to you, awesome. If it doesn't, we've got two more that we'll practice out. But again, overall steps. First thing, what are you solving for? Second thing, write down everything that you knew or were given. And then third thing, I like working backwards. What's the final equation? And then kind of figure out what we need to plug in from there. In terms of the second problem that we have, let's talk Nalgene bottles. I toss an Nalgene bottle to one of my friends. If the bottle has a volume of 1,100 milliliters and a density of 2.3 grams per milliliter, then what's the momentum that the bottle is thrown with, assuming I tossed it 2 meters in a time of 3.8 seconds. Alright, lots of stuff there, but they're asking, what is the momentum? So we know that we're going to search for P, momentum. Alright, so let's figure out what else they gave me. Volume. So volume equals 1100 milliliters. I also know that I was given density. So density of 2.3 grams per milliliter. 2 meters is going to be a distance. So distance equals 2 meters. And I've got a time of 3.8 seconds. So time equals 3.8 seconds. So right away, again, I like working my way backwards. P equals mass times velocity. I know that I'm searching for P. I know that I have not been given, at this point, it doesn't look like mass or velocity, which is kind of awesome. That means I'm going to have to solve for both. In terms of what seems easier, if there's an equation that you know off the top of your head, velocity is it. Velocity is displacement divided by time. So let's try that guy out. We've got a velocity equals displacement divided by time. Again, we could plug in some quick numbers. V equals 2 meters divided by 3.8 seconds. And all of that is going to give you a nice little velocity equals about 0.5-ish, 0.53 meters per second. And that whole thing kicks into here. So we've got times 0.53 meters per second. Awesome. So we've got another equation that we could use to solve for mass. We've used our displacement time, but velocity and density, or volume and density will help us solve for mass, because we know that density equals mass divided by volume. And so when we look at our density, we've got 2.3 grams per milliliter equals our density, equals our mass divided by our volume. And our volume was that 1,100 milliliters. So again, multiply each side by 1,000 to figure out what your actual mass is, and we're going to be left with a mass that is equal to 2,530 grams. Now, we do have a slight problem here. This is in grams. This needs to be in kilograms. So along the way of transferring from here, this 2,530 grams, to here, we need to convert. And we're converting from grams to kilograms. So in order to actually do that, we're going to move the decimal over 3. 1, 2, 3. And we would really have 2.53 kilograms. So in order to find that momentum here, I take P and I take 2.53 kilograms times 0.53 meters per second, and I am left with a nice little 1.34 kilograms times meters per second. So our momentum is going to be 1.34 kilograms times meters per second. So again, what are we looking for? What's our final purpose? Finding that. What's the equation for that? And then how can we use everything else that we've been given to solve other equations that will lead to solving for mass and allowing us to have velocity so that we can actually plug those into our current formula. Okay. So moving on to question 3. Let's work our way down, give ourselves a little space here, and let's go. Alright, so our final problem. We got 5 minutes to kick this out. Empty can is sitting on the ground. Child kicks a can, it reaches a final velocity of this, the can has a volume of that, it has a density of this, it's kicked with a force of this. How long of a time did the can move before it reached the final velocity of that? So we know that we're looking for time. Time equals question mark. Other things that we were given. Empty can is sitting on the ground. Sitting on the ground is a giant clue. We know we're dealing with VI is 0 because it's motionless. Kid kicks a can, reaches the final velocity, VF, of 7.8 meters per second. Kind of useful there. So we get that. Our next one, can has a volume of 355 milliliters. So volume equals 355 milliliters. And our next one, density of 8.1. So density equals 8.1 grams per milliliter. And finally, it was kicked with a force of 14 newtons. So force equals 14 newtons. And we've got final velocity there, but we've already set final velocity. It's this yellow thing, so we can ignore that. Alright, so at this point, we know that we are looking for time. We have two basic equations that have time in it. V, velocity equals displacement divided by time. And we've got acceleration equals VF minus VI all over time. I have not been given distance or displacement, and I have not been given velocity. I have, however, been given initial velocity and final velocity, so I figure this is as good a place to start as any. If it doesn't work, we could start over and try this thing. But I like starting with A equals VF minus VI all over T. Okay. In the process of that, I know that acceleration equals that. We are searching for time, so we'll throw the red T there. VF is going to be our 7.8 meters per second minus VI of 0 meters per second. But I've still got to solve for acceleration. So my other equation that solves for acceleration is force equals mass times acceleration. So whatever this is going to go right there. I have been given a force. It's 14 newtons, but I have not been given a mass. And so I need to solve for mass as well. And the most useful way that I can do that is density equals mass divided by volume, knowing that I've got density and volume right there. So my density is going to be that nice 8.1 grams per milliliter equals mass divided by, and our volume was 355 milliliters. I multiply both sides by 355 to cancel out, and I'm going to end up with a mass equals 2,875.5 grams. So this whole thing needs to get shifted into here. But I have a problem. Specifically a problem with that and that. This guy is in kilograms up here. This guy right here is in grams. So along this moving, I need to convert from grams to kilograms. So in the process of that, I really move the decimal over 1, 2, 3, and I end up with 2.876 kilograms times A. And so to figure out my actual A, I divide both sides by 2.87. So 14 divided by 2.87, or approximately 3, is going to give you a nice little acceleration equals 4.86 meters per second squared. And again, this whole thing is going to follow this arrow right here. So you'll end up with a 4.86 meters per second squared equals 7.8 minus 0 divided by t. And when I rearrange all of that, I'm left with a t equals 1.6 seconds. So once you isolate for t, you were left with 1.6 seconds in order to move that kid kicking that